Good morning. Here's a little instructional video that I'm going to try to teach compound interest. A lot of what we're doing on the 9C notes, but I think this is going to go a little bit quicker here. Um, so first thing that we want to talk about with when we have these problems with interest rates, that interest rates are always calculated per year. Okay, interest rates are always going to be calculated per year, and so that's going to sort of how this stuff is set up. So if we were to ask this question, right, if we deposit $100 in a bank account at 12% interest, how much money would we have after 12 years or after 4 years, excuse me. All right, simple exponential function. So we have 100 is the amount of money that we start with, and we're going at 12% interest. We're going to go 1 plus 0.12, and we're going to raise that to the fourth power. Okay, so 100 times 1 plus 0.12, so we're going to have 100 times 1.12 to the fourth power, just like we've already sort of done the last few days. Okay, so if we go to my calculator here, we have 100 times 1.12 to the fourth power. We're going to end up with $157.35. All right. Now, this is different from what we're going to do. We're going to add sort of a layer onto this. This example shows that if you got paid 12% interest just once per year. Okay, so basically, like at the end of each year, the bank gives you 12% of what you have in your account. Okay, that's if they just give you interest one time per year. So when I'm talking about compounded interest, if we're thinking about what does it mean to compound? Okay, compound is just when they give you interest. Okay, so a compound is when you get interest money. So in this example, you got interest money at the end of each year. Okay, you got 12% at the end of each year. Now, if the interest rate was compounded more than once per year, what we would have to do is divide the 12% interest rate by the number of times it was compounded. In addition, we'd also have to, our exponent would change a little bit. Okay, and here's how. So just a quick little explanation here. If you want to pause the video, take a minute, and just sort of read through this. I'm not going to talk about it. Just pause the video and read through this stuff here real quick. And when you're done, then restart the video. We're going to go to the next page. So back to our original equation here. We had $100, investing it at 12% after 4 years. And we had our answer, which is $157.35. All right, now let's say we deposit $100 in a bank account at 12% interest compounded semi-annually. Okay, semi-annually. Well, semi-annually is twice per year. Okay, so semi-annually we need to sort of branch this off here, and so we have our 12% interest of 0.12, but it's compounded twice a year. So we're going to divide that by 2, and so our actual rate is going to be 0.06. All right, so here's what this means. So now we're going to have $100 going into the bank, and we're going to multiply by 1.06. Now, here's what changes, okay? So we're going after 4 years. We're going after 4 years. Okay, however, the interest is compounded semi-annually. It's compounded twice a year. Okay, so we're not going to raise it to the fourth power anymore. We're going to raise it to the eighth power. Okay, because it's compounded twice a year, 2 times a year, at 4 years is really going to be 8 to the 8th power. So we're going to have 100 times 1.06 to the 8th power, okay? So we're still getting 12% interest, but instead of getting 12% at the end of each year, we're getting 6% twice a year, okay? So instead of getting 12% 4 times like we did up here for 4 years, we're going to get 6% 8 times. So we go and do that. We have 100 times 1.06 to the 8th power. We're going to have $159.38. All right, same thing. We have $100, 12% interest compounded quarterly. Okay, so quarterly is 4 times per year because there's 4 quarters in a year. So we'll take our 0.112 interest and divide it by 4. And so now we're going to be at 3%. So we're going to have 100. That's not good. We're going to multiply that by 1.03. Now, quarterly, there's 4 quarters in a year. There's 4 quarters in a year, and we're going after 4 years. So 4 quarters in a year times 4 years is our exponent. So now it's going to be 100 times 1.03 to the 6th power, or not the 6th power, excuse me, the 16th power. Okay, because the interest is being compounded quarterly, we're compounding it 4 times per year. So after 4 years, you're getting your 3% interest 16 times. So 100 times 1.03 to the 16th power, now we're going to have $160.47. So hopefully we're kind of seeing the more that we compound the interest, the 12% interest, the more money that we're actually going to make. Do these last two. All right, $100 in a bank account, 12% interest compounded monthly. So we have our 100, 12% interest, so 0.12. There's 12 months in a year. So it's going to be 0.01. So we're going to multiply that by 1.01 here. 12% interest compounded monthly. So what happens is there's 12 months in a year. There's 4 years. So we're going to raise that to the 12 times 4 power, which is a 48th power. So you're going to have 100 times 1.01 to the 48th power. That's going to give us $161.22. Finally, if we go to this last one, if we deposit $100 in a bank account at 12% interest compounded weekly, well, if we're thinking weekly, there's 52 weeks in a year. So if we have 0.12 divided by 52, our rate is going to be 0.0023. So very, very, very small number. Okay. However, we're going to raise that to a much bigger power. So we're going to have 100 times 1.0023 Okay. There's 52 weeks in a year. And if we're going for 4 years, that's going to be 208 total times that we get paid interest. So now we're going to raise this to the 208th power. So raise that to that power. Now we're going to have $161.26. Okay. That's sort of the simple math of it. There is a formula to it, but before I explain the formula, I kind of wanted to explain this. Hopefully it kind of makes sense. And when we come back on Monday, we'll look at the formula and do that, and hopefully the formula will make a little bit better sense to us. But I wanted us to sort of see what it would look like with the same numbers, but different ways that we compound it, and hopefully you kind of see the difference here. So let me know if you have any questions. Get this stuff copied down, and best of luck. Thank you.